Hi, welcome to the lesson data types 2, int, double and float. There are two types of number data types. One is the whole numbers or integers and one are the decimal points. They are called floating points in programming language. Uh, how do you declare and initialize number data types? Well, the method is the same as with the strings. For example, if you want to declare an age variable, you'll write var for variable age, then the name and then the type. The age is usually an integer, so we'll write it as an integer and is equal to 31. Like this process, this line does two things. One is declaration. This is the declaration part, and this is the initialization. Initialization, like appointing the value for the first time. You could have also, if you want to declare and initialize with a 0, you could do this as well, int and two brackets, and this will initialize the age with 0. Obviously, we cannot redeclare a variable, so it has to be age 1. Similarly, if it was a double variable, you will write double here and double here, and obviously double variables need to have decimal points in them, 5.3. As you know, Swift can infer the number type as much as it can. So if you write something like this, variable score is equal to 5.3, it knows that it isn't an integer, so it won't initialize, it won't infer it to be of type int. It will have the choice of double or float. So it will by default suppose that it is a double. You can check that by type of, okay, and then write the variable, okay, and let's run this and see what happens. This is of type double. Okay, if you wanted to declare the score to be float, you'll have to write the float keyword here. Okay, so this is how it goes. Capacity, the int variable has a certain capacity. It cannot hold a number bigger than the capacity. For older device, the capacity was something like between -2 billion to positive 2 billion. Any number within this is an int could hold. For new devices, however, this limit has increased quite a lot. It is 10 raised to power 18, minus 10 raised to power 18 to plus 10 raised to power 18. So this is something to keep in mind, that int cannot hold infinitely large numbers. If an int will hold this number in a program, you'll get a runtime error. So to avoid that, just to make sure where you can use int, where you can use double and float. Double and float, they have different accuracy. For example, a double can hold many decimal points, for example a bigger number like this, but if you save this number into float, it will truncate it will truncate decimal points but only keep 5 or 6. So float has an accuracy of 5 or 6 decimal points, and double has about 15. So these are the things to keep in mind when deciding which data type to have. Type inference we have discussed already. Conversion between types. One thing about Swift is that you can only do operations within one type. For example, if you have to multiply, let's do it, multiply the above two variables, for example age and height. Okay, age is an int and height is a double. So let's multiply and see what it says. It says binary operator multiply cannot be applied to operands of type double and int. So what we need to do is we have to convert both of the variables have to be in the same type, whatever it is, but it has to be on the same type for the multiplication to work. So what we can do is we'll have to convert, if you convert age into double, it will work. Okay, so the way to convert into double is write double and then within brackets put that variable. So now this is a double, this is a double, the multiplication can happen. Similarly, you can you could have done this as well, multiply 1. What you could have done was you could have done age multiplication and converted height into int, but Obviously, that is what this will do is this will convert height into int in a way that it will truncate the decimal point. This is now 5. Okay, so age is 31 and 5 is going to be something like 155. So this is sort of compromises the accuracy of the number. So you will lose significant digits, if you will. And the last thing before we close this lesson is that you can write for large numbers like this. It's a big number, it's a million, it's difficult to read. You can put underscores anywhere if you want. Similarly with the negative numbers or decimal numbers, you can do that. And in fact, you can put underscore anywhere you want.